All right. Hey, everyone. Welcome to the Teleport Database Access webinar. My name is Roman, and I'm an engineer on the Teleport Database Access team. And today I'm just going to talk to you about present you Teleport Database Access, give a brief overview of what it is, why we're building it, how it works, give like a quick demo of the functionality, right? And we'll have some time for Q&A as well at the end. So let's go over the agenda real quick, right? So first, we're going to talk about the actual problem of securing database access, right? To define a problem space and understand why we're building this in the first place. Then we're going to spend a couple more minutes about looking at how it works, right? About talking about its architecture on a very high level, just so you understand what's going on behind the scenes. So then we'll do a quick overview of the features, jump into a quick demo, and talk about some release schedule, about what's on the roadmap, and hopefully have some times for some questions as well at the end. All right, so let's get into it. So first, before we actually talk about Teleport specific kind of database access, why we're building it, let's take a look at the actual problem space, right? So when you think about what it means to provide a secure access to the database, what does it mean, right? So what's the actual problem space here? And so a few things come to mind here right away, right? So the most obvious concern probably is protecting and segmenting access to your data or different data stores that you use in your company or organization. So this issue, if you think about it, has really multiple angles to it. Like one being, for example, the question of network isolation. So do I expose the database endpoint directly to my users, or do I require some sort of VPN, which usually are cumbersome to set up, maintain, and use, things like that. So in addition, organizations of any size or company of any size likely have multiple different instances of databases they want to protect. And you can have like a production database, you can have a staging, a QA database, maybe like a database with some sensitive customer data that requires some special treatment, and so on and so forth. And so when thinking about setting up access to all these different databases, you're inevitably faced with questions like, how do I give my engineers full access to staging and be able to grant them temporary access to production in case of emergency, for example, right? Or how do I make sure that my QA team only has access to QA databases, things like that. So you can control access on the level of individual database server, usually by using databases on grant systems, but providing access to different kind of database instances and servers, especially if they're of different types, in a coherent fashion may not be as straightforward of an issue. So another question that comes up is a question of identity. And in many cases, the same database account or a set of accounts tend to be used for database access by different people, right? It's similar to a problem which hopefully is kind of not as common these days, but it used to be back in the days when all developers or engineers used to connect to servers using the same Linux account, right? There's obviously an anti-pattern, and there are multiple obvious issues with this approach. Everyone is kind of aware of. One being, it obviously erases identity of a person connecting to the server or database. It basically obfuscates the audit trail completely, right? It makes like revocation painful and so on and so forth. And so in the context of database specifically, many database servers support external auth systems, like such as LDAP, for example, but they generally come with a pretty hefty maintenance burden, pretty painful to integrate with, and like befriend them, so to speak, with different identity providers. So the ability to basically be able to add single sign-on SSO flow to a database login would allow to answer questions like, who connected to this production database as Postgres user, for example, right, in case you were using Postgres. So on a very relevant note, a proper database access audit trail is basically a must for various compliance reasons. So you should be able to answer the questions like who executed like select wildcard SQL statement on a production database, right? Or try to access the data that they shouldn't have to detect things like data exfiltration, for example. And combined with identity information we discussed a minute ago, this would give us a complete picture of what's going on with the database access. Setting this up natively within the database, again, especially for traditional relational ones, is generally not as straightforward and poses quite a challenge, as most of the time, the best you can really do is enable verbose logging, for example, or maybe install a third-party plugin that does this, which is usually kind of database specific and pretty hard to do and maintain, especially in scenarios where you have multiple different database instances in your company. And another bonus point here that's worth mentioning is also if you are able to ship the audit log to some external system for future analysis, for example. And one last issue I just wanted to mention before we move on here, which may not be as common, but which larger organizations are bound to run into eventually, is providing access to databases in different environments and controlling access to them in a unified manner. So an example would be, having databases deployed in multiple clusters or data centers and wanting to control access to all of them through a single unified access plane. So you can see it. These are just some of the questions to think through when thinking about the problem of securing or protecting the database access. And addressing each of these issues individually can pose a challenge. But combined together, it makes it quite hard, to provide secure and unified experience that doesn't really stand in the way of your users. And so we're building the database access to help overcome some of these challenges. All right, so now let's take a look at this. Probably every engineer's favorite slide with a lot of arrows and squares. And so this slide really gives a high-level overview of how Teleport database access works, right? So for folks who are familiar with Teleport, this should look pretty familiar, as it's very similar to how server, Kubernetes, or application access work. For newcomers, it should give a pretty good high-level overview, high-level understanding of the overall architecture. So this diagram shows an example database deployment. So in it, we have the following components. So first, let me turn on the pointer. So the first component we're going to look at is called a Teleport proxy. And Teleport proxy is basically a stateless service that performs a function of like an authentication gateway. It serves a web UI and accepts, in our case, Teleport database client connections as well, right? So within the database access context, this is basically the piece where your database clients connect to, and it's usually exposed on a public network to users. Then there's a Teleport auth server, which is basically a cluster certificate authority that handles authentication, authorization, and performs a job of issuing short-lived client certificates to the users, right, including database access users. So Teleport, just as a quick background for folks who don't know, Teleport relies heavily on public infrastructure internally, right? And it pretty much uses client certificates, SSH certificates or X509 TLS certificates as a primary means of authentication. And so this is what Teleport auth server does. And next, finally, we have another component that's called Teleport database service, which is a new one. And it basically is the database access's brain that actually connects to all the databases, performs database authentication, does protocol parsing, and it connects back to the kind of main teleport cluster by establishing an SSH reverse tunnel to the proxy, right? So in this architecture, in this model, users do not need to have direct connectivity to the database service or any of the databases even, right, that it proxies, but rather, as long as it can dial back to the cluster's proxy service, it can be located behind the firewall, for example. And another thing to mention here is that you can obviously have multiple database services connected back to the cluster, and each database service can, be connected to multiple databases as well. So the deployment strategies can be pretty flexible. All right, now that we're familiarized with the architecture, let's take a quick look at the typical flow that database access users go through when they want to connect to a database. So once, first the user logs into the cluster by issuing a TSH login command, right? So for folks not familiar with Teleport, people run this command to go through authentication flow, and they can authenticate using their username and password or second factor auth, or go through an SSO flow and have Teleport auth server issue them a short-lived client certificate that they then use. Once they have been issued a client certificate, they basically, user picks a database they want to connect to, and will obviously see all of those things in the demo, which we're going to do in a minute. So once they have chosen the database they want to connect to, they can connect to it using the standard database client. You can use, in case of Postgres, it's pSQL client, standard client tool, MySQL in case of MySQL, or any of the graphical UI clients also. And so connect to the proxy using client certificates issued by auth to authenticate. And the proxy authenticates a connection, dispatches it to appropriate database service based on the routing information encoded in the cert and over the reverse tunnel. And from there on out, database service kind of starts proxying the traffic between the database client that user uses and the actual database. And so you can also see here on the right, so there's some examples of a database that may be connected to the database service and authentication methods used, right? So for self-hosted databases, the preferred authentication method is client certificates. And in case of AWS, for example, it's IAM authentication. All right, so that's the architecture. Hopefully it's now more or less clear how it works under the hoods. Let's quickly go over some of the features of database access. Right, so first, like explained on the previous slides, it's possible to connect multiple instances of supported databases to a single Teleport cluster, and also configure appropriate role-based access control rules to allow or deny access to specific database instances based on the identity information propagated from your SSO provider, for example, as well as restrict access to specific database accounts, or in some cases, for some databases, even individual logical databases within your database servers, right? Which is the case for Postgres, for example. Then security-wise, which is, technically not a feature, strictly speaking, right, but rather property of the system, which I already mentioned, but thought mentioning it again, is that Teleport uses short-lived certs, client certs issued by the auth server to authenticate with the database, and users get issued short-lived credentials so that expire after some period of time, which is configurable to authenticate with the database. And all communications, obviously, between the users and Teleport, as well as communication between internal Teleport components, relies on mutual TLS for authentication as well. So next, Teleport, talking about audit log, right, going back to those problems that we discussed on the first slide. So Teleport actually captures all SQL statements executed by users connected to the database, which we'll also see during the demo, and ships them to the audit log, to the teleport standard audit log, which already collects information from all the other subsystems, like server access and others, which can also be configured to be shipped to some external system for future analysis. Database access also has obviously been, one of teleport kind of features. It has a first-class integration with such teleport features as access workflows that allows the users to temporarily request elevated permissions, for example, right? If you want to access some particular piece of infrastructure or like a database, in this case, they don't normally have access to. And finally, trusted cluster support is also there, right, to provide unified access to the databases in different clusters or environments. All right, so now is everyone's favorite part, demo time. Let me exit my presentation here, and let's hope that the demo gods are in a good mood today and jump into it. So hopefully everyone can see my screen. I'll need my terminal, my editor, and my browser for this. So I'm going to switch between those. And let us start by looking at my cluster's configuration, right? So in my case, for this demo, I have just a single node cluster that runs all of three of the services. If you remember back to the diagram, auth service, proxy service, and database service running in the same process, just for the demo purposes. And let's take a look at the database service configuration a bit closer. So you can see, and this is regular teleport YAML file for folks who have used teleport before. So as you can see, the database service in my case provides access or is connected, I should say, to multiple different database instances, right? So each of these blocks here represents a single database connection. And you can see I have like a healthy mix of Postgres and MySQL databases here deployed in different environments. So I have two instances of self-hosted DBs, which are just running, Docker container somewhere. And then I have an Postgres RDS instance, Postgres Aurora cluster endpoint, and MySQL Aurora endpoint as well, right? So this database service is connected to multiple databases, and each of these, as you can see, can be assigned a set of static or dynamic labels that can be used to allow or deny access through teleport's RBAC, role-based access control. And you can see that in this case, I have, so the local database that I have just have the label environment local, and the others have environment set to AWS. All right, now that we've pretty much laid out the playing field, let me go to my terminal and start doing things, right? So first thing that I can do, or that I will do rather, and I'm going to be copying, pasting commands from my cheat sheet here. But the first thing that I do is I really need to do this first authentication step that I mentioned on the architecture slide, and retrieve authenticate with my auth servers of my cluster and retrieve a short-lived cert. And so I'm going to execute the TSH login command, which hopefully succeeds. It takes me through the SSO authentication flow because I have a couple of SSO providers configured for my cluster. And if we go here to the teleport control panel of my cluster, you can see I have Okta and GitHub in this case configured. So that logged me in and retrieved me a client certificate, right? So now I'm authenticated to the cluster, I have credentials, and in order to be able, let's say I want to see what kind of databases I have access to and connect to one of those, right? So for that, I can execute the command that's called TSH DBLS. Right, so that basically, once I've run this command, you can notice I'm presented with a table that shows me all the databases that I can see, so to speak, and connect to right now. And you can notice if we like going back to the gut configuration file, you can notice that I'm only shown 2 of the databases that are available to me. And so this is because my current teleport role, which we can see here, which is called admin, but it actually kind of provides access to only subset of all the databases that we'll see in a second. So it only allows me to see the databases or access the databases with a particular label. So let's switch back. Let me enter my control panel here of my cluster and demonstrate real quick the role. So this is the admin role, the role that I got when I went through that SSO flow. And you can see that the way it's configured is I'm only allowed to see the databases with a label set to local, right? So that's why I can't basically see any of the other databases connected to my cluster. So okay, that's fine for now, right? So let's kind of try to just connect to one of these databases and see what happens. And like we learned before, Teleport uses client certs as a primary method of authentication. And this is like obviously the case for database access as well. And in order to actually connect to one of these databases, the first thing what I should do is to retrieve these credentials, these short-lived credentials, this short-lived client cert for the database I want to connect to, right? And so the command that I'm going to run is called tshdb login, very similar to tsh login or like other counterpart login commands that we have, like for Kubernetes and whatnot. But in this case, it's called db login. And if we take a look at the flags here in a little more detail, you can see that I'm specifying the name of a database I want to log into. So in my case, I just want to get into this Postgres DB that runs in a Docker on my machine. And I'm also specifying a couple of flags. So this is the user that I want to kind of connect as, and the database, the logical database within this Postgres instance, Postgres server that I want to connect to, right? And these are just specified here for convenience. They will serve as default username and database name. They can obviously be overridden on the command line when actually connecting to the database. All right, so let me go ahead and launch this command. So now I've retrieved my short-lived credentials and got issued the client cert. And now I can actually go ahead and establish connection to the database just using normal psql command line tool. So let me, and the output of this command actually gives you a little hint. And before I do that, let me also show the output of tshdbls. You can see that it's now indicating that I'm logged into this particular database and gives me a quick hint on how to actually connect to this database. All right, so now I'm inside the database. Let's execute a couple of queries, just something simple, so it doesn't accidentally nuke my database here. So now let's go back to my teleport control panel and just take a look at the audit log capabilities, right? So just to reiterate, I've basically logged into the database. I executed a couple of queries. And if I go back to my audit log here, this is just standard teleport audit log UI. You can see a number of audit events have popped up here that basically tell me that my particular user, teleport user in this case, connected to a particular database on a particular database server and executed this query and that query, right? So in this case, this particular query is actually what psql sends to the server when you do this /l to see the list of all available databases. And for each audit event, obviously, we can see that some of the details, more detailed information in a structured form that tells you, particular session ID that can help you to correlate the events within the session, like a full query text, database account name, and so on and so forth. Cool. So now while I'm still here, let me try something else, right? So you can see that I have a number of different databases here, logical databases. So Postgres treats those like completely separate entities, right? So you have to actually reestablish connection if you want to change the different database. So let's see what happens if I try to reconnect to the database that my teleport role doesn't have access to, or that doesn't allow me to connect to, right? So in this case, I can't basically switch my connection to any of the others from the current database, right? Just because teleport RBAC kicks in and doesn't allow me to, returns me access denied there. All right, so let me close this session for now and make sure. So yeah, the database access denied event has also been captured in the audit log, as well as the disconnect event. All right, so for the next scenario, let's kind of quickly take a look at the feature we call access workflows, and how it integrates with the database access. And so for this scenario, let's assume that I need an emergency access to one of the other databases that I can't normally see, right? Like some Aurora instance, for example. And let me go ahead and execute the command, just copying over here. So it's a TSH login command with a request roles flag, which basically what it does is it on behalf of my user, it sends a request to temporarily grant my user this additional role, right? So in my case, the role that I know will grant me access to this other kind of set of databases is called DB, right? So I'm going to go ahead and request this additional role for my account. And in my case, I'm just going to go ahead and approve my own request. And I'm doing this from the command line just for the sake of speed. But teleport access workflows can also integrate with Slack, PagerDuty, and a number of other providers. And in the 6.0 upcoming 6.0 release, you will also be able to approve or deny request through teleport web UI as well. All right, but for the time being, I have approved my request. My request got approved, right? So I've been granted an additional role, which is indicated by this line here in TSH status now. And now let's see, yes. So now when I run the TSHDB login command, I have gained access to a kind of broader set of databases. In my case, all the databases with the AWS label have also become available to me. And I can really, from here on out, I can do the same thing I just did with Postgres. So just for the sake of trying it out, let's try to log into this MySQL Aurora database, right? So the process is absolutely the same, very similar to Postgres. So I've retrieved the credentials. You can, I'll expand this a little bit so it doesn't wrap. So you can see it can be logged into multiple databases at the same time, right? So they don't kind of interfere with each other. And I retrieved credentials for a MySQL instance, and now can use standard MySQL command line client to connect to an Aurora instance as well, right? So show schemas, run a couple of queries, and make sure, take a look at the audit log as well, right? To make sure that these queries have been captured for this instance as well. All right, so one last thing I wanted to demonstrate is that graphical clients can also be used with database access. And for this, as long as they support client certificate auth, which most of them do. And let's take a look at FPGAdmin 4 here, which is a kind of standard, so to speak, Postgres graphical UI client. So let's go ahead and quickly go over how you would configure PGAdmin to talk to, I'm going to use the same local instance to connect. And for this, I'm just going to go ahead, create a different instance of the connection. I'm going to call it local. When populating all the fields here, I actually don't need the port, don't need the username, but rather just need to specify the name of the connection service file. or rather a section in a Postgres connection service file that tshDB login command updates, and verify full SSL mode. So let me save the connection, and so you can see that the connection has been established. We have connected to can see all the databases within my local Postgres DBMS, and from here I can execute SQL queries and so on and so forth. And you can see that 2 of the databases I actually don't have access to, and if I try to access to, I get the same access denied error, just because my teleport role doesn't allow me to connect to those. And obviously, everything you do through pgadmin gets captured in the audit log as well. So you can see that there's a lot of stuff going on here, a lot of queries that it runs behind the scenes. All right, so let me quickly disconnect it from here, close pgadmin, and wrap up the demo by just logging out of everything and finishing up my session. All right, so this concludes the demo. Hope it was interesting and useful. So let's get back to our slides for now. Just have a couple more slides to go over. All right, so here I just wanted to say a couple of words about how database access fits in with the rest of the Teleport ecosystem. So if you're somewhat familiar with Teleport already, you know that it started as a server access tool, adding RBAC, auditing session recording capabilities on top of the SSH protocol. And over time, we really added support for accessing Kubernetes clusters, and with the most recent 5.0 release, application access as well, right? Making it a first step toward what we call a Teleport unified access plane. And the idea is of Teleport unified access plane as a central gateway, providing access to any infrastructure resource. And so database access really is just another, albeit quite big piece of this puzzle, and sort of like a logical continuation of the whole UAP idea that builds on top of the existing robust teleport platform, and just sits there alongside all the other resources like servers, Kubernetes clusters, and applications. Cool. So let's talk about release schedule a little bit, what's currently supported, what's on the roadmap, as we keep kind of working on building the database access and making it better. And so initially, we're focusing on supporting 2 of the most popular traditional open source databases, which are Postgres and MySQL. So Postgres support is already available in the 6.0 alpha release, which we published a couple of weeks ago. And it includes support, as you could have probably told from the architecture and from what we've seen right now, it includes support for both self-hosted Postgres databases, as well as Amazon RDS and Aurora Postgres flavored instances. So MySQL support is coming next with the same deployment modes of self-hosted and AWS hosted databases, and it will be available in the 6.0 general availability release that's slated to release in a couple of weeks on March 1st. Probably chances are to land in one of the beta releases we're going to be putting up pretty soon in the next few days. And yeah, like I already mentioned, we're kind of working on improving the database access, building it out, right? Adding more features and protocols over the course of this year and beyond. So stay tuned and feel free to follow our blog, our roadmap on GitHub to kind of see where it's moving. And finally, for the next steps, just wanted to leave a couple of helpful resources, hopefully, that you might want to check out if you want to learn about database access in more detail, or even like kick some tires on it. So there is first, there's a quick 5-10 minute getting started guide that we've created that should help you set up database access with an Aurora instance. Then there is a more in-depth documentation, which we're actually working on overhauling for the big 6.0 release. So hopefully it'll be even more useful then, but feel free to check it out. It has a ton of information, including more detailed architecture and RFD document. And yes, so finally, everything we've talked about before and everything we've seen is available in the open source version. So you can go ahead and download that alpha release I mentioned before, even right now by going to our downloads page and trying it in action. Right, yeah, and finally, I think that's it for me. Thank you for your attention, everyone. Hopefully that was useful and interesting. And I think we do have some time left for questions and answers.
Yes, we have several questions and we still have plenty of time. So if you have any questions, please submit them through the Q&A. The first question here, I believe this might have been already answered, but I'll ask anyways, is I see that AWS RDS Aurora is supported. Is AWS RDS MySQL supported?
Yes, it's supported.
Perfect. Next question here is, how are other databases added to Teleport once Teleport is deployed? Can it be added through the API CLI?
So right now, it's a good question. So right now, it's added through this static configuration file, like I shown during the demo. And we do plan to eventually add support for adding like databases, adding and removing databases dynamically, through the API, or maybe even like through some sort of self-registration when it comes to Kubernetes or things like that. So, yeah.
Perfect. Next question. I know we already answered part of this, but the question was around what other databases are supported, whether Snowflake or Redis are part of that.
Yeah, it's a good question. Again, like I said, first, we just want to focus on covering the the large part of the landscape, right? When it comes to databases, there's probably like an infinite playing field, infinite tail of the databases to support. So I feel like Postgres and MySQL cover a lot of this. For the next, there's no, at the moment, there's no Snowflake on Redis. I would say kind of stay tuned and follow our roadmap to see what next protocols we'll be adding. We'll certainly have plans to keep adding more database support, but we haven't kind of ironed out the full list of those that we'll add. It probably will be mostly driven by like a customer like demand, I would say, right? So yeah.
Perfect, thank you. Next question here was the YAML file that you showed at the beginning, which lists the databases with the environment tags. What is the client? Was that the client configuration file or the server config?
Yeah, so the YAML file I showed in the beginning is the server configuration, right? So it was actually the configuration for Teleport database service, as well as Teleport auth service and Teleport proxy service. Yeah, so for the client configuration, if you mean like a database client configuration, like a T-SQL, MySQL, or any of the graphical, so you don't need to worry about any doing any special configuration for standard CLI clients, like I showed. For example, for T-SQL, MySQL, you don't need to edit any config files because tshDB login command will do everything for you. If you're interested in a little bit more details, we're using what it's called for Postgres. It's connection service file, right, which TSH will pre-configure when you log into the database. For MySQL, it's the option file, I believe it's called. So yeah, so for those, you don't need to worry about them. For graphical clients, you do need obviously to configure them to point to proper, like database host, which in our case is going to be Teleport proxy address, and the credentials. But we will have kind of detailed instructions about how to configure various graphical clients with step-by-step instructions and screenshots and other stuff in our documentation pretty soon. So yeah, chances are if you're using any of the graphical clients, to connect to the database, it'll be kind of present in our docs, how to configure those.
Thank you. Next question we have here is, how do you manage the database credentials?
Yeah, so this is a good question. This is kind of like a pretty broad topic, right? So when it comes to, it depends on what you mean exactly, right? So there are multiple kind of layers to it, as I think. So first, there's credentials, what I would call database accounts, right? So which are the accounts that you provision within the database users, right? So you can have, like, an example would be this Postgres user that by default is a super user in every Postgres database, or MySQL user, or I think it's actually called root in MySQL, right? That you have in the MySQL database. And so these accounts obviously still need to be kind of present in the database itself and provisioned. And then when it comes to teleport, as I showed the role before, am I still sharing?
Yes.
Am I still sharing? Let me, so I don't just talk and rather show. If I go back to my roles section here, I can take a look at my role that I have here. You can see that in addition to this field that's showing like DB labels, which controls access to all the database servers I have access to, I also have control over what database accounts my role can use, right? So in my case, the role that I used in the beginning of a demo, which only allowed me to see the local databases, it basically allowed me to connect either to use a database account named Postgres or a root or a Roman T. So if I try to connect to any database using any different database account name, the attempt would be obviously rejected, right? So that's how the mapping works on the teleport side, or rather how it's enforced, on the RBAC layer. So now once a user has connected to the database, right? So teleport basically controls, at this stage, it controls the access to the database. So once you have connected to the database successfully, whatever you can do inside the database is governed or like controlled by the database's own like a grant system. So you can configure different grants in both Postgres and MySQL, right? To grant users access to specific parts of the database, like specific tables, run specific queries, so on and so forth. And plus, when it comes to the roles here, an important kind of property of the teleport RBAC, which is kind of convenient, I think, is that all of these fields can be like templated. So you can see there's template variables examples shown here. And those values can be propagated from your identity provider as well, right? So let's say in my case, I have my cluster connected to Okta and GitHub. We also support OIDC connectors. And you can use your identity provider basically as a central inventory, like to define, like, for example, which users or groups have access, can connect to like which databases or use which database accounts, right? So these things basically can come from your identity provider. This way, when the user goes through the SSO flow, these fields will be kind of substituted with assertions in case of SAML or claims in case of OIDC, right, coming from your identity provider. And this way, teleport will enforce like proper RBAC on those. So hopefully that answers the question.
And there's a clarifying question on this, is the Roman user that you're showing us here has a password. If so, where is that password configured?
Yes, so this user, it doesn't have password, right? In this case, like I mentioned before, teleport uses client cert authentication mechanism currently to connect to the self-hosted databases. So, or rather, I should say, there's actually two use cases here, right? So there's self-hosted database and there's RDS or Aurora database, which are kind of have a little bit different authentication models. So in self-hosted database, we're using client certificate authentication. So you configure your database users to authenticate not using a password, but rather using a client certificate. which Teleport database servers generates on kind of a demand on the behalf of a user, right? So in my case, this Roman T user, for example, it doesn't have a password in the Postgres database, but rather it requires a valid client certificate signed by a proper certificate authority to kind of pass authentication successfully. So then the second scenario in case of AWS Aurora database or just regular RDS, there we use IAM authentication, in which case Teleport basically handles the generation of like a proper IAM token on behalf of a user and using that as a password to authenticate with the database.
Thank you. And this, you may have answered part of this question, but this is, does Teleport RBAC support managing permissions for specific tables or views, support managing specific actions such as read and write on those tables or views?
Right, yeah, it's a great question. So as I explained, currently it supports the connection part, right? So it enforces a connection as a proper user or a proper database name. And once a user has connected, this is whatever they can do within the database, it's still like governed by the database zone grant model, right? In future, we do have plans to look at the more kind of extensive, like how you would name it, more extensive RBAC model for databases potentially, where you can, control what specific parts of a database, like what specific tables the users have access to, right? Or what specific actions they can take within the database. So yeah, but not in the initial release is the short answer.
Thank you. Still have quite a few questions, so we'll keep going here. Next one is, Postico is a very popular database access tool that is widely used at Gladly. And I don't believe it has option to enter a service. Do you know if this feature works with Postico?
Yeah, so we'll take a look at, I can't recall off the top of my head, unfortunately. I think we've looked at Postico. I don't remember, honestly, if we had gotten it to work successfully or not. I think so. As long you don't necessarily need to specify service, right? You can also specify, like enter all of those. When configuring a GUI client, you can basically manually enter address of the database, like host name, port, or paths to all the secret files. And let me actually show you real quick. So if I go and I'm not logged in, so let me, just for the sake of kind of giving a complete answer here, logged into the database, DB login. Let's say I want to log into this Postgres. And so if I execute tshdb config command, so this command, we specifically implemented it to kind of ease the process of configuring GUI clients. And you can see that it gives you pretty much all the information you normally need to configure like a connection to a GUI client. So yeah, as long as Postico supports client cert off, you should have no troubles getting it to work, right? We'll obviously also consider this, adding this to our guides for graphical clients. So yeah.
Thank you. Next question here is more around how Teleport compares to PAM tools.
It's a good question. So Teleport, I mean, Teleport in general is sort of a PAM tool, right? So it's a kind of privileged access management tool. When it comes specifically to database access, if you mean like configuring PAM within like a database to authenticate, it comes with its own, I guess, kind of maintenance burden, right? You need to have a separate PAM tool and configuring every single database to like refer to that PAM tool to kind of authenticate or provision user for you. So it's kind of a broad question, to be honest. I'm not sure how much in detail you want to go into this right now. But yeah, in a nutshell, I think we do say that basically Teleport is a privileged access manager tool. If you want to kind of simplify things a little bit, right, with a ton of additional features on top of that, such as, kind of structured audit logging, session recording, access to all these different types of resources, with the idea of being kind of universal gateway to like all of your infrastructure resources, things like that.
Yeah, that's great. Thank you. Next question here is the idea that the proxy component can be deployed anywhere and the database service is deployed potentially on-prem behind the firewall? Just wondering if you have considered combining the proxy and the database service components.
Yeah, it's a good question. Yes, so you can, let me read it, so proxy component deploy. Yeah, so like I said, deployment model is pretty kind of flexible, right? So you can have the database service like be co-located with a proxy within the same process, or you can have the database service sit behind the firewall, right, on-prem. And like I said, it doesn't even require, in this case, you don't even need to expose the database service publicly anywhere. So it can sit behind the firewall as long as it, has this outbound tunnel to the proxy. So yeah, like for this demo, you might have noticed and like I mentioned, I was using like a single process mode where I run everything kind of in the same process, which is obviously not suitable for production, right? But for quick, trying out it's pretty convenient mode of operation as well. Yeah, but in general, you can, by all means, you can have your database service sit somewhere behind the firewall in a bunker, without like any ingress, right? To only allow an outgoing connection to the proxy service, which is probably from a security standpoint is kind of the preferred approach.
Thank you. All right, still got a couple of more questions here. Next one is, what is the level of access control on database level for user? Can we restrict specific tables like SQL operations such as insert, update?
Yeah, I think I've answered it already before. So at the moment, Teleport kind of controls the connection layer, right? So it only allows you to connect as a specific database account to a specific database, or potentially a specific logical database in case of Postgres as well. And in future, we certainly do have plans to look at more kind of in-depth access controls, including restricting specific tables, or maybe like schema security, data obfuscation, things like that. So stay tuned to see how it will develop.
Thank you. And final question here in the queue is, will Teleport connect to the actual database via generic database user? For example, how many users should I create on the database side for Teleport?
Let me see how many databases. Yeah, so Teleport, yes, so you do need to have, so Teleport, when Teleport connects to a database, it connects to the particular database account, right, that you actually specify yourself. So for example, in this case, I'm connecting as my default kind of user, whatever it may be, right? But I can also override this. Am I still sharing, by the way? Yeah, I think I am. Yes, so I can specify, I don't know, like user QWERTY, right, which I shouldn't have access to connect as this user. But yeah, this is how you specify user to connect, right? So when it comes to Teleport, to users on the Teleport side, it's not really, basically you don't need to create a specific user on the Teleport side per your user in a database. So I think the general model that would be not too painful to maintain and make sense is have for example, preset number of database accounts within the database with predefined permissions. So for example, I don't know, you could have like a viewer role, right, that only is allowed to see a part of database, execute select space statements, so on and so forth. You have more privileged role that can, perform some DDL or like inserts and things like that. And then you just map users of your organization to like whatever database accounts they can assume when connecting to the database, right? So in my case, for example, if I don't have access to a database user called admin, I won't be allowed access to the database as user admin, right? So I think it's rather a question of teleport user usually maps to a like a particular person in kind of your company or organization, right? Which usually comes from your identity provider. And then from there, you can really configure role-based access control to grant or deny access to particular database instances or database accounts. Hopefully that's clear, and we can talk more if it was not.
Thank you. And we did get a couple of more questions. I know we're approaching the hour. So next question here is whether there's any plans on improving the installation process, and the questions around Helm charts or perhaps chart per service.
Yeah, I think we certainly do have plans on improving that. So I believe we do have a Helm chart that can install like a that basically for Kubernetes access, right, and for application access as well. So obviously database access will get integrated into all that machinery as well, right? So yeah, the simpler the installation process, certainly the better. If you do have any specific suggestions on improving those, something you're struggling with, something you don't feel like could be better, we're always welcome kind of GitHub issues. Feel free to go ahead, and if it's something specific for database access, feel free to kind of mark it with an appropriate label, and we'll certainly kind of open to improving that part.
Thank you. And a couple of more questions here, which I think we can ask in one. Do you currently support databases for other cloud providers? And there's also questions around support for CockroachDB.
Yeah, so CockroachDB is not supported at the moment. For other cloud providers, so as a first step, we're targeting Aurora and RDS, and we're also going to look at making it work with Google Cloud SQL as well, right? So I haven't taken a very close look at it yet, but I do think so. As long as the cloud provider supports client certificate authentication, it kind of should work out of the box, right? For some cloud providers like Google Cloud SQL, I know it does require a little bit of kind of tweaking to make it work in a kind of user-friendly fashion. So which is going to be our focus after initial release. So yeah, stay tuned.
Thank you. And that is all the time we have. We really appreciate everyone for joining today. You will be receiving the recording of this webinar along with the slides. And thank you, Roman, for a great presentation.
All right. Thank you, folks. Thanks, everyone.